Um, so now that we have all of our ODEs and all of our functions, now after you run this line, you're going to have all the solutions. Now what we want to do is to find ABV. So as same thing as we did before, we're going to go ahead and use our ABV equation here. And we're going to put it down here. So we're going to say that ABV is actually our 5.8 times 100 and then times y. Again, for this part, don't forget that the y that you're looking for is your last y. So how do we get that last number? Remember, if we have, for example, I'm gonna help you out, but like imagine if we have an a vector that is 1 2 3 and then 4 5 6. So it's a 2 by 3 matrix. And so in our case, we're going to have 5 columns. This one only has 3. But imagine we wanted the last value for our third column, for example. We just wanted the, which is what we want, right? We want the last number for a particular column. Then what we would do is we would say A, and then we tell it we tell it that we want the end one, and then we tell it what column we want it to be. So if we want 6, for example, we would say 3. And then that'll give us 6, okay? So apply the same reasoning for this one. So tell it you want the last value of the 5th column, and then times whatever. It's not 5.8, actually it's like 5.837 times 10 to the negative 5, and then times 100. And then that is going to be your ABV. Then what this does is going to put that ABV value into actually we can call it something, to make it clear, let's just call it AB, and then that's going to be a number, and then we're going to have this is just a little change I made, but you can do it the other way as well. Is you have to make it a different name basically, otherwise when you run it again, then it's gonna erase what this was before, if you understand. So we want to call it anything you want here. Let's call it like alcohol percentage, and then that's going to be for these particular conditions. Right now we want to have that one stored in our ABV vector. So you can either do this, but there's also a different way. I'm going to show you how to do this, which is you can just make each one of the ABV values in the vector. And to do that, you can just say ABV of I. So it's basically the one that corresponds to that temperature. I would advise you to do it this way and not the way that's in the format. It's just a little easier. It's just one line. And then you can just say ABVI and then copy and paste your equation for ABV. And that's it. Yeah. So remember here it's end and 5, right? And then instead of doing these 2 lines how it is in the template, I would just do it like this. So basically you're creating each one of your ABV values at a time. So for example, if I run the first time, I'm gonna have all my Arrhenius values for 10 degrees, right? Then I'm gonna have my ODE for 10 degrees, and then my answer is for 10 degrees, right? So basically what I'm saying is now create one that corresponds to 10 degrees, which is the first input, and then give it that. Then at the end, we're gonna have a vector of ABVs that is gonna have the same length as your temperature vector. Now at the end, the only thing you need to do is to plot it. So again, we plot it how we plotted before. No difference there. And that's it, I think, for part 4.